spotted by the James Webb Space Telescope, something that looks pretty wild. City lights way out in space. These lights are 7 miles wide, 1 trillion miles from us, and they have everyone debating whether there is life in the wild. Telescope was examining Proxima Centauri b, the exoplanet closest to Earth, when it observed these bright spots. Are they cities? It has excited people because, for ages, scientists and regular folks have hoped to find evidence of life beyond Earth. So, this is significant. The telescope noticed these weird, city-like flickering lights on Proxima Centauri b. It's like seeing a glowing city in the distance, which raises the question of whether there is an alien civilization living there. It's a little mind-blowing, because it could imply that there are civilizations elsewhere we don't even know about yet. These city-like lights are so far away, it's difficult to comprehend. NASA scientists probably want to know how long those lights have been there. Perhaps they've only been waiting for us to become sufficiently advanced to see them. David Kipping, space expert from Columbia University, says this star system is especially interesting. Explains that it heats differently from others. Typically, rocky planets absorb sunlight and release infrared light. But Proxima Centauri b's infrared signature is distinct from its star, which provides a clue. The James Webb Space Telescope excels at spotting infrared, so this unusual heat pattern from Proxima Centauri b could be key to figuring out what its atmosphere is like. Now, researchers are using the best infrared cameras to study the planet's atmosphere, hoping to discover evidence of life on that faraway world. Because the James Webb is so good at detecting infrared light, it can even see Proxima b's dark side and pick up the faintest glimmer, something other telescopes struggle to do. This means it might actually confirm whether those city lights rumors are true. The telescope can identify artificial light in the universe. It's within a very particular wavelength range. How Proxima Centauri b orbits its star is interesting. The sunny side of the planet has tons of solar panels soaking up energy, while the dark side reflects light to keep things balanced. Day and night are centered around its star-like Earth, but it gets blasted with sunlight during the day and freezes at night. The temperature difference depends on the planet's atmosphere or lack thereof. Without much atmosphere, the extremes would be severe. The James Webb can study the planet's heat to better understand its atmosphere. Plus, because the telescope's alignment with Proxima Centauri b's orbit is favorable, scientists can observe its day-night cycles in just over 11 Earth days. They believe Proxima Centauri b may have a climate and want to see if its atmosphere contains gases such as methane and oxygen, positive indicators of life. Despite the telescope's exceptional skills, examining these components is still tricky. While it can study only a handful of nearby habitable planets, astronomers are looking forward to larger ground-based telescopes beginning operations in 2028, which will examine atmospheres more closely. For now, the James Webb is the main tool for studying these distant worlds. It has limitations but remains crucial for understanding planets outside our solar system. Researchers are also working on future telescopes that can block a star's bright light using masks or umbrella-shaped satellites to focus on the faint light reflecting off a planet's surface. These new instruments will help determine whether detected gases come from living things or from geological processes like volcanoes. Even with such challenges, astronomers remain determined to find signs of life. The James Webb marks a huge step forward in this quest, giving us a glimpse of the amazing things that may be waiting to be discovered. The search for life has been ongoing for decades. People have always wondered if we're alone in the universe. In 1984, Jill Tarter and Thomas Pearson launched the search for extraterrestrial intelligence SETI to detect radio signals from space. Since radio waves can travel vast distances without distortion, they used 42 radio telescopes in California to listen for such signals. 30 years later, nothing definitive has been found, but Jill Tarter remains optimistic and invites others to join the hunt. The discovery of Proxima b's possible city Lights has made this search for alien civilizations even more exciting. The James Webb is one of the best instruments for uncovering the universe's secrets. Its advanced technology can see through space dust, revealing how the first galaxies and stars formed. Named after James E. Webb, a key NASA leader during the Apollo missions. The telescope's instruments, cameras, and spectrographs work together to give us stunning views of the cosmos. Its massive mirror, made of small segments, can detect faint light from the earliest galaxies. Operating at extremely cold temperatures, it spots weak heat signals from distant objects. Since launch, it has exceeded expectations, showing us the farthest galaxies ever seen, revealing how stars form, how galaxies evolve, and how planets take shape. The possible detection of city lights on Proxima b is a landmark moment in the search for life. More investigation is needed to confirm what these lights really are. But the telescope has undoubtedly opened a new chapter in our understanding of the universe, whether or not intelligent life exists there. The discovery has renewed interest in whether planets like Proxima b could be habitable. It's too early to say if the lights are real or an illusion, but if they are signs of life, it would change everything: science, philosophy, and our place in the cosmos. The James Webb is central to this investigation. Without its sensitivity to faint light, we wouldn't see much of what we now observe. Beyond Proxima b, it's helping scientists study other distant planets' atmospheres for possible signs of life, while no definitive evidence has been found yet. Researchers are getting closer by analyzing light passing through a planet's atmosphere. Scientists can detect gases like oxygen, methane, and water vapor, all often linked to life. But detecting these signals is challenging. They must also confirm weather conditions such as temperature, atmospheric pressure, and surface composition could support liquid water and life. The James Webb will keep monitoring Proxima b and other targets, providing vital data on their atmospheres and surfaces. This is just the beginning of a new era in the search for extraterrestrial life. Researchers are working to figure out if it could be another Earth, while everyone is excited about Tauri b, Proximus, and the city lights. Scientists are being cautious about rushing to judgment. There are numerous things that might account for those lights, from natural materials to potential artificial sources. Just like any other discovery, they need to do more research before they are completely certain. The telescope will play a big part in this search, because there is more to life than one planet. Researchers are looking everywhere for signs of life on distant worlds. As technology gets better, astronomers are hopeful that we will eventually discover evidence of life beyond Earth. The James Webb Space Telescope is only the beginning of this new era of exploration, giving us the instruments for comprehending the vast, complex universe we currently inhabit. The discovery of those possible city lights has reignited the pursuit of intelligent life. The notion that there may be civilizations waiting out there to be found is thrilling to think about. For years, we have been searching for alien life, focusing mainly on detecting signals. Now we have a telescope that can directly observe far away planets and even search for artificial light. This alteration in our methods could be a game changer in the search for knowledge about life beyond Earth in the future. The search for life will keep evolving. The telescope has already given us amazing insights into the possibility of life existing elsewhere. But there is still a great deal to learn. Scientists will continue improving their methods and building new technology to aid us in locating evidence of life in the universe. The coming years will likely be filled with discoveries that challenge our perception of life itself. The development of new telescopes, like the LT Extremely Large Telescope, will help us study distant planets in unprecedented detail. Scheduled to begin operations in 2028. The ELT will be able to examine the atmospheres of exoplanets with great precision, giving scientists key information to determine whether these planets could sustain life. By combining the capabilities of the James Webb Space Telescope with the ELT and other observatories, Researchers will be able to conduct more in-depth studies of exoplanets, despite the challenges ahead. The search for life remains one of the most important scientific pursuits. Proxima Centauri b's possible city lights are only one of many exciting opportunities. As technology advances and our comprehension deepens, we are prepared to discover substantial information that could alter our perspective on life. The James Webb Space Telescope will continue to lead the way in this exciting journey, investigating far-off exoplanets like Tauri B and Proxima Centauri B and revealing more about the potential for life beyond our solar system. The study of these faraway worlds offers fresh insights, not only into the possibilities of alien life, but also into the conditions that allow planets to support life. Proxima Centauri B's discovery has sparked international interest, but it is only one of many exoplanets under investigation. The significance of the James Webb Space Telescope lies in its ability to detect faint signals from planets once undetectable by earlier telescopes. Its infrared technology allows it to observe light that has traveled across vast stretches of space, revealing essential details about exoplanets' atmospheres, surface conditions, and potential habitability as scientists refine their approaches to studying planets. The telescope is providing new perspectives on exoplanet environments, perspectives that could yield crucial indications of the existence of life. Exoplanets like Proxima and Tauri B are located in what scientists call the habitable zone of their star, the area where conditions may allow for liquid water. Water is considered essential for life as we know it, but scientists must also factor in other conditions such as the distance between the planet and its star, atmospheric composition, and the ability to maintain a stable temperature. While Proxima Centauri B is in a habitable zone, its surface conditions are still being studied to determine whether it could support life. Another exciting frontier is the study of exoplanet atmospheres. The James Webb Space Telescope can detect their chemical composition by analyzing how starlight passes through gases like oxygen, carbon dioxide, and methane molecules often associated with biological processes on Earth. Detecting these gases on distant exoplanets could provide the first tangible evidence of life, though their presence alone would not be conclusive proof. Scientists are also exploring the possibility that life could exist in forms very different from what we are familiar with, while much of the search focuses on Earth-like planets. Researchers are considering the potential for life in extreme environments. For example, in the subsurface oceans of icy moons like Europa or Enceladus, or even in the clouds of Venus, where trace gases could support microbial life. These possibilities expand the scope of the search and challenge our existing notions of what makes an environment habitable, beyond the search for life itself. The study of exoplanets and their atmospheres can teach us more about planetary formation, processes, and the evolution of star systems. Understanding how planets form and what makes a world life-sustaining can also deepen our knowledge of Earth's own history. By comparing Earth to distant exoplanets, scientists can identify characteristics that make our planet unique and pinpoint the factors that allowed life to emerge here. The technology used in the James Webb Space Telescope is also paving the way for future advancements in space exploration. While it continues operating, future telescopes such as the ELT and the GMT Giant Magellan Telescope will build on its work, enabling scientists to collect even more detailed information about distant exoplanets. These future observatories will provide additional tools for studying the composition and conditions of exoplanets, further advancing our understanding of where life might exist in the universe as we continue this search. The James Webb Space Telescope has already given us a glimpse into a new era of exploration, one in which distant planets are no longer just points of light in the sky, but worlds that can be studied in depth. With each new discovery, our understanding of the universe deepens and our sense of wonder grows. Even if we do not find definitive evidence of life, the exploration of exoplanets helps answer one of humanity's oldest questions. Are we alone in the universe? The journey has only just begun. With the tools we have today, the possibilities are endless.